What is it again? 0.312.
Is it 0?
No, not into this function. Yeah, it better be 0, right? Because that's the slope. But I want to know how high above the ground it is, which means I need the original function, don't I?
Right.
But we understand I'm talking about the green function here?
Yeah.
Yeah, I know the slope is 0. That's the way I solved it, right?
Right.
I would have expected that. Okay.
What is that, the 3125 seconds, right? Seconds.
Okay, 0.3125 squared minus 16, which gives you 5/16, isn't it? Actually, negative 25 over 16, my bad. Negative 25 over 16, is that what you all got?
Is it 41? 5, 6,
Okay, anyway, you substitute it in, and you get negative 25 over 16, plus 50 over 16, which is 25 over 16, you add that to 4, and you get 5 and 9/16, which is 5 point.
5.56.
Okay, approximately. So in other words, my maximum point, my maximum height is going to occur at 0.3125 seconds, and it's going to be how high? 5.6, some more? 25? 5.5625 what? Feet. Seconds, and that's feet. Everybody see how I found it?
Yeah.
So that's the height.
The height when it tops out, right? It's maximum height. A lot of times we're interested in maximum and minimums of functions. It's nice to be able to find maximum and minimums of functions. This is how you do it using calculus. Now I'll show you how you do this on your graph. Your graphing calculator can do this without any calculus. All you have to do is graph that function and zoom in at the top and just keep zooming in, and pretty soon you get the maximum height, don't you?
Yeah.
Let's take a look at it. You guys have a calculator? Go ahead and pull it out. I would have handed them out and had you do it that way, but it takes too long. Let me just put it up here for you.
I'll do it. Oh.
Okay.
That's a sick
Okay, we're going to go to y equals. Here's my function. Negative 16x squared plus 10x plus 4. That's my function. Now I'm going to put it in standard so that we can see what it looks like when you put it in standard. In a standard graph, it's going to be the full parabola. It's not going to be just a piece that we were looking at before. To find the piece that we were looking at before, we use what? What do we change? So it's a W.
Window.
We change the window to x is 0, right, when we started. And it's only going to be a few seconds. So maybe I can go out to 4 seconds. Y, I'm going to start out maybe at 0 and go up as high as 6. So it'll kind of fill my screen a little better. And we can graph it. Looks a little bit nicer maybe. But it's happening all in less than 1 second. A little faster than I expected. So let's just go ahead and change my window to 2. There, that looks a little nicer. Now I want to know when this thing tops out. So what I can do is if you press your arrow keys, you'll notice that you get this nice little crosshairs here. And I can put it up near the top. 0.32 and 5.5. Not a bad estimate. I can get a better estimate by zooming in. So I go to zoom, zoom in. Sorry. Now I want to zoom in on that point. So I press enter. Now what I do is I just adjust my point a little bit. It's right in the middle. Looks like a better estimate, but I can zoom in again just by pressing enter. And enter again.
Keep entering.
Got to keep centering it every time.
Again.
Now I'm pretty darn close. 3.124 and 5.562. If you want exact answers, your calculator doesn't cut it. It's close. It's really close. But when you're talking about astronomical distances, like when you send a probe out to Mars, or worse yet, to the Jupiter's moons, you're talking about having to be correct to maybe 1,000 decimal places. you have to work with exact answers. At that point, computers and calculators won't do it. What they do is they actually adjust it in flight. But when they send that first trajectory, they do it by hand to make sure that it's an exact answer. And the only way to do that is using calculus and finding exact answers, using that nice little special H value.
Don't they shoot it and once they shoot it again and recalculate?
Yeah, that's what they do. They recalculate as they go, but when they send it up the first time, they generally want to have a pretty good idea where they're going. They don't want to be off by a couple 100 million miles, right? And they can only adjust so much. Remember that they have limited fuel they can send up on space probes. And they actually ended up, the Voyager ended up going about 100 times farther than they ever expected. And it just kept sending back images for forever, it seemed like. So it was wonderful.
Do you know the regular format for the Windows? It's -10.
-10, 10. Yeah, just press Zoom standard, Zoom 6.
Oh, okay.
Zoom 6 will always take you back to standard.
Oh,
You guys get the idea?
yeah.
Okay, you need to read in your book, and I want you to imagine, this is a one-day lesson in calculus. This is your first day in calculus you're going to do this.
Oh, really?
This is the first day. You come in, they start out, they tell you about h, and they actually plug the h into the function and talk about the limit as h approaches 0. It's a very, very complex idea. But don't worry, you guys will get it. Your assignment for Monday, you need to get started on it. You're going to take 153, this is the homework, 3, 5, I believe. Let me get it out. No, homework 3-6, page 153. We do 1 through 14 all, 15 to 51, every other odd. And the special questions are 16, 20, 24, 30, and 44. Uh-oh. They started early.
Not too many.
They supposed to have an atomic clock, but I think it's off. I know my watch is pretty accurate.
Yeah, mine
And through Monday?
Yeah, Monday. But I like to take a good start on it so that, you know, I can actually answer questions about it and that sort of thing. Give you a good idea. For those of you going to the SAT seminar, I realize you're not going to have a chance. Yeah.
Oh, no. Oh, no.
12:50. Something like that, 12:50. Oh, that's all right. Everybody good? Got it written down? Let me show you what this is used for.